Let's look at the first problem. Evaluate the following expressions. Approximate your answer, if necessary, to 3 decimal place. The first one, a log 27. Here you don't see a base. The missing base implied that this is a common logarithm with a base of 10. Therefore, this is log 10 27, and this is something that you can directly find from your calculator. The symbol right here, so all you need to do is to enter 27 and then hit this log key and approximate this answer to third decimal place, which will be 1.431. That's the first problem. The second one, this is an exponential expression with the base of the natural base constant. So again, this is also an available function in your calculator. On this particular calculator, I have to hit the inverse key to get this button, e to the x power. Therefore, all you need to do is to first enter this x, this exponent, in this case negative pi plus 1. So we would have pi, negative sign, plus 1. This is now the exponent, negative pi plus 1, and then all we need to do is to find this exponential key right here and then hit it, and the answer will be approximated to the third decimal point, 0.117. The next problem, this is something we can apply the inverse property, because a equals to function fx equals to a to the x power, and also another function, let's call it function g, x equals to log ax. Because these two functions, they are inverse functions, therefore we know that their composite function must equals to x. Okay, and here this is an expression of a composite function of fx equals to 5 to the x power and gx equals to log 5x. Okay, this is the composed in a way that fgx equals to 5 to the log 5x power. And because of that, the evaluation will simply be this x, which in this case 20. So this is a problem that you do not need to use the calculator to solve this problem. All you need to do is to understand the inverse property of the exponential function and the logarithmic function. So this we know for sure the answer is 20. Next problem, ln, this is a natural logarithm. So this is log, which has a base of e 8.24, and again this is a usual function on your calculator, this key right here. So all you need to do again is to hit 8.24 and then this ln key. So this approximated to the third decimal place will be 2.109. Last problem, again, does not require calculator. log 4 to the 116 and 1 over 16. So for this problem right here, if you are having trouble understanding it, write this as if it's equals to a question mark and rewrite this logarithmic expression into its equivalent exponential expression. If you recall, exponential expression a to the b's power equals to c, and logarithmic expression log a c equals to b, these two expressions are equivalent of each other. Therefore, to rewrite this logarithmic expression into its equivalent exponential expression, we will have 4 to the question mark's power equals to 1 over 16. So now our goal is to find 4 raised to what power equals to 1 over 16. And we know that 1 over 16 equals to 1 over 4 to the second power. Therefore, it equals to 4 to the negative the second power. Therefore, the answer to this problem is -2. Next problem, solve equation for x. To solve x from this equation, we are going to apply the one-to-one property of exponential function. Okay, one-to-one property states that for exponential function, fx equals to a to the x power. If a to the x1's power equals to a to the x2's power, then because of one-to-one property, x1 must equals to x2. Therefore, if we can rewrite the right-hand side into 3, again to question mark's power, then we can apply the one-to-one property and solve for x. And we know that 1 over 9, similar to the previous problem, equals to 1 over 3 to the second power, which equals to 3 to the negative second power. Therefore, we have on the left-hand side 3 to the x minus 4th power equals to, on the right-hand side, 3 to the negative 2th power. Therefore, by applying the one-to-one property, x minus 4 must equals to negative 2, and x equals to negative 2 plus 4 positive 2, and that will be the solution to this equation. The next one is a logarithmic equation. We are going to solve this one again by applying the one-to-one property of the logarithmic function. Again, for a function fx equals to log a x, if log a x1 equals to log a x2, then because of one-to-one property, x1 must equals to x2. Therefore, here as you can see, these two logarithmic expressions, they have the same base. Therefore, we can apply the one-to-one property right away, which will have x squared minus 3 equals to 2x. Rearrange this, x squared minus 2x minus 3 equals to 0. We notice that this is a quadratic function. We know how to quadratic equation. We know how to solve for quadratic equation. We factor it, x minus 3 multiplied by x plus 1 equals to 0. Therefore, x equals to 3 or x equals to negative 1. It looks right, however, because of the domain requirement, whatever is here has to be bigger than 0. Because of this, we realize that x equals to negative 1 does not satisfy this domain requirement of the logarithmic function. Because if x equals to negative 1, then this term equals to log 5 negative 2, which is invalid. Therefore, this has to be eliminated. Therefore, the solution can only be x equals to 3. Last problem is a graphic problem to sketch the function fx equals to negative log 2x minus 1. We're going to graph this based on the parent function. Let's call it gx equals to simply log 2x. This is a logarithmic function with a base that is bigger than 1. Therefore, the graph will have the general shape that is an increasing function. It will have the x-intercept of 1, 0, and also it will have vertical asymptote that is the y-axis, which is simply x equals to 0, vertical line, and the graph will be always increasing. So here is a general shape of this graph. But this is a gx function. This is not an fx function. We're going to sketch our fx function based on this parent function. Now we know that, first of all, we have x minus 1. This indicates a shift to the right by 1 unit. And then we have this negative sign, which indicates the reflection about the x-axis. Therefore, first, this graph is shifted to the right by 1 unit, and it will now have a new x-intercept, which is 2, 0. And also, it will have a new vertical asymptote, which is x equals to 1 line. And then it is flipped about the x-axis if you just draw the reflection of this graph right here. So based on these conditions, we can now draw the fx function. It has a vertical asymptote that is x equals to 1, it has a x-intercept that is 2, 0, and because it's a reflection about the x-axis, therefore the shape will be a decreasing function shape, and that will be the sketch of this function.